Hello and welcome to Engineering at Harper Adams University. My name's Sam Wane, I'm the course manager for the Applied Mechatronics Engineering Award, and I thought I'd show you around a little bit. So here we have a typical teaching laboratory, hands-on, computers, all the software, MATLAB, SolidWorks, microcontrollers, which we get out when we're teaching them at the time. So let's go through to the front of the class and see what we've got. I thought I'd just show you a brief campus plan. This shows you that we are surrounded by a working farm, and we have sports pitches, a soil hall, an off-road track, and lots of other areas where we use to teach agriculture, so veterinary science, land management, etc. We also have a working dairy which has robotics in. It also houses the famous hands-free farm, which was a completely robotically farmed project. Here's an example of some of the items that we've got. Autonomous tractor, and we have a lot of drones around here too. And just an idea of some of the buildings that we have, the Agri Epicenter and the Agri Precision Laboratory area too. So we do a lot of projects here to do with self-driving cars, strawberry picking, vision systems, deep learning, and as you can see, some of the self-driving pods that we've worked on, and a self-driving tractor as well. And laser weeding was another of our projects, and I'll take you up to the laser weeding laboratory in a minute. So we have 4 taught modules that you can see there. We have 2 research modules, and we have the advanced mechatronics module and the robotics in agriculture module. And underpinning all of that is we have a large project, so a major project, which is a research project. And we like to have a hands-on project with applicability, often in agriculture, but it doesn't have to be. The mechatronics, Applied Mechatronics Engineering is it's quite a small award, so there's some pictures here where we have students, and you can see that there's probably about 10 or 15 students here, but it's more or less a one-to-one support. So let me tell you a bit about some of the modules that we have. So we have the 2 research modules. We also have advanced mechatronics module, where we look at things like sensor fusion, auto code generation, Kalman filters, communication systems. And then we have the robotics in agriculture. So this is a module that's very unique to Harper Adams, where we get hands-on use of robotics in farming, image processing. We learn about machine states and behaviours, and focusing not only on mobile robots but also robot arms that could be used for example, picking strawberries, etc. So let me take you around some of the working laboratories and the research areas that you can see. So here we are just outside the teaching laboratory, and you can see that we have Daisy the cow here, and we have about 400 cows at the university, and this is an example of the sensors which are on a lot of our milking cows. So for example, most of the cows are fitted with foot pedometers, which can analyse the health of the cow. Okay, we're in one of the teaching laboratories here. You can see one of the robot tractors which has been used in many of our projects, robot arm for picking strawberries, planting things, and it's a fully functioning laboratory with all of the bits. And you might notice up at the top there is we've got some drones attached to the wall as well. They're spray drones. So here we are in one of the research laboratories where we've developed things such as laser weeding. We use robot arms for a variety of things. You'll see we've got a laser scanner project going on here, which is looking at safety in autonomous tractors, and you can see we have a laser scanner which is on test, and you can see the results of the output from the laser scanner, and it's plotting the trajectory of a tractor that might move, and to see if it would be in a safe path to move or not. And if we'll have a look outside, I'll show you outside. So this is a view outside the research laboratory, which is a pretty good view really for a laboratory. And we've got our precision farming agriculture experiment out here, where we're looking at controlled traffic farming. But pretty much as far as you can see is the part of the farm that we have, and we have lots of land to test robots out and tractors and different types of techniques. And this is a project we've been working on recently, which was an electric quad bike, but we've now put a differential GPS receiver on. As you can see, those two antennae on the left and right, which uses high accuracy GPS to determine which direction the vehicle is facing. So that drives itself outside, is connected to the network. And you'll see here we have a multitude of a variety of projects, which are different projects in situ and being made up as part of different projects.
So what we have here is a robot which has two GPS receivers on the left and the right, and it uses the difference in the GPS values that it reads to calculate its heading. So it's a true heading rather than a magnetic heading. And you might notice that there's a linear motor which is steering the robot left and right, and it's driving by itself to some waypoints.
We have some workshops here, vehicle workshops. Students are working on a variety of off-road vehicles in their own time. It's got a new 3D printing facilities where we can rapid prototype items, and we have a router, that's a router, we have a CNC machine and a coordinate measuring machine right here. The machine is pointing out to us. He knows.
Scanning system, 3D scanning system over there in
Yeah.
the corner too.
3D scanner just over here. Right. So here we are in the hydraulics teaching lab. So you see that I'm surrounded by different machinery for stress testing, hydraulics, and over here we have a classroom. It's quite useful that it's connected to this laboratory. Right, we'll go and see the soil hall, which is a large indoor arena where we can test out vehicles in all sorts of weathers. Just before we do, we'll see some more of the hydraulic training rigs that we have. So welcome to the soil hall. It's a huge 60 metre by 30 metre area where we can run trials in all sorts of weathers, and we can change the ground. We can add water to it, we can plough it up, we can do all sorts of different experiments in here. As I just go over to the far end of the soil hall, you'll start to see something that we do with our undergraduate students, and that's a robotics course. So it's an off-road robotics course, and it's part of their assessment is to design, build, program a autonomous robot system to get round a course which includes all sorts of obstacles, ramps, and a scoring area at the very end as well. So the robot has to go around this course, staying within the boundaries and getting through the obstacles, and go over the ramp and down the seesaw down the other end, and it has a scoring system at the very end. What we'll do while we're walking is go into the machinery hall. You can see ahead, which is another space about the same size of the soil as the soil hall, and you'll see that it's just completely full of machinery. You can hear something starting up. There's a 4x4 starting up in the far corner, and over on the right there is the big yellow combine harvester, which is from the Hands-Free Hectare project and Hands-Free Farm project. So we're going to finish our tour back at the engineering building. My office is there, and that's all of the laboratories. So I hope you've had a enjoyed that brief tour. It's a nice day here, and hope to see you in the flesh pretty soon.